Hi there, so this is question 3. As I mentioned on the 2A paper, which you may not have seen if you studied 2C, question 1 and 2 I've covered in 2B, and in the playlist it's going to be the same videos that I use for 2B, but the questions for question 1 and question 2 are the same across all 3 papers. So we're starting off with question 3 today. A boat is travelling at a constant speed on a straight canal. The boat travels at 150 meters in 60 seconds. Calculate the speed of the boat. So speed, distance, and time is what we're going to use. Distance is 150. Time is 60 seconds. So this is going to be 150 divided by 60, which gives us 2.5. And that unit is meters per second, and that just gives it to us on the answer line. Okay, question 3 continues over the page, where we've got a child is cycling on a path next to a canal. The child sets off when she is level with the front of the boat, and the graph shows how the distance travelled by the child and the distance travelled by the boat vary with time. So we would imagine that the boat would continue at a nice, smooth rate because it's going down the canal. So we'll say the straight line is the boat, and this line that varies will be the child. Sorry, a bit tired. My child kept me up all night last night, which shows that sleep's really important when you're doing maths. Honestly, before your exams, get a good night's sleep if you can. State all the values of t when the child is level with the front of the boat. So we've got this one here, which is where they started off. We've got this crossover point where the child with the bike catches up with the boat and overtakes, and then the child decides to slow down and the boat will not overtake. We assume it would overtake, but it will reach level with the child at that point. So we've got t is equal to 0. Now time is on the x-axis, so we've got t equal to 0, t equal to 30, and then finally t equal to 60. Okay, question 3. Use your graph to estimate the speed of the child when t is equal to 30. So t equal to 30 is going to be this bit here. Always read ahead. Read all of your questions. I'd hate for you to have drawn all over this. And then you need to draw this line here. So in order to do this, we need a tangent. I think that's pretty good. That's pretty good. Draw my tangent like so. And then from that, I'm going to need 2 crossover points. Just click off the screen because that's... Okay, so our first point, let me get rid of that I'm going to take is when it was 30, we had 75. So we've got 30, 75. I'll explain what I'm doing in a minute. You need 2 coordinates for this. So where else do they cross over? This one's pretty good. Just there. So that's 20, 38. Okay. So when we work out the gradient, it's the amount it's gone up divided by the amount that it's gone across. That's distance divided by time, and if you recognize that, that's going to be speed from our speed, distance, time. So the gradient on these graphs is going to equal the speed on a distance time graph. So finding the gradient will find the speed for us. So within this, it's gone from 20 to 30. So for the up, over, across, the across bit, 30 take away 20, and then we've got the up 75 take away 38. That gives us, I'm going to use my calculator. Can't be doing that with my lack of sleep at the moment. 75 take away 38 is 37 over 10, and that gives us 3.7. Now, I don't have the mark scheme with me, but you will be given a range, and I've actually wrote the range down on my notes. The range of the answers is going to be 3.5 to 4.5. So if you've got an answer in there and you've shown you're working, you're going to get full credit for this question. Okay, the distance s travelled by the child at the time t is modelled by s equals 1/8 t squared take away k t cubed. Work out the value of k. Now, what I need is a value of s and a value of t. Where's my screen gone? I've just gone past the graph. And we've got one that we used earlier, 30 and 75. So I'm going to use that. S equals 75. and t will equal 30. So 30 seconds, that distance is 75, and we substitute that into the formula. So 75 equals an eighth times by 30 squared, not to the power of 4. Where's that come from? And then k times by 30 cubed. So 75 equals 30 times 30, 900, divided by 8 is 112.5. Take away 30 times 30 times 30, 27,000 K. Now if I add that on both sides, and then I subtract the 75 from the 112.5, I've got 1.5 there, and then we divide. No, we haven't. I've divided. I needed to subtract. Idiot. 112.75 take away 75 gives us 37.5. Apologies about that. 0.75. And then we're going to divide that by 27,000, which gives us 0.00139814. But if I hit my SD button, I've not got the right number. I've put the wrong thing into here. Go back. 112.5 take away 75 is 37.5. Oh, my core maths class always say I've got loads of errors. Hopefully they don't watch this one. Okay, this is 1 over 720 once I've hit the SD button, but it's also 0.00138. And whichever answer you give, you'll be fine. I like to leave it as a fraction because it's nice and accurate. Okay, that's question 3 done. Sorry about the waffle. Hopefully the rest of these questions will be fine, and I'll see you at question 4.